One have to be functions,
F minus x equals to f of x, right?
right? And they got symmetry with respect to the origin. Cool. Not any odd function has symmetry with respect to origin. There's an image. Here's another image. The sine curve. How's the sine curve? Sine curve goes like this. The sine curve, y equals sine of x is an odd function. Just a couple of examples. Odd functions. Cool. But this image, can we make a sketch of it? It's got the x cubed on this side, right? Well, what's this do on the right side of the piece? Now I noticed they're both connected at 0, and so it is a continuous graph. It is continuous, right? But I'm sorry, is that symmetrical with that?
No.
All right, A is out. Sorry, it's not an odd function. What's letter B?
Is it discontinuous?
That's false. They said it's discontinuous at 0. Everyone, it is continuous at 0. B's out. It's
Limit.
one of the remaining 3. C, the limit as x approaches 0 does not exist. False. The limit does exist. We can see it. Right? Left side of limit equals right side of limit. True? Right?
Mm-hmm.
Cool. That's not it.
F
It exists. It's either D or E is the true statement.
D is not true too.
D says
prime of 0.
f prime of 0 equals 0. Now I'm going to put a question mark. We got to see if this is true or false.
This
That's
false.
probably the hardest part to this problem. You know what that means, everyone? We're looking at slope. And this is what we got to look at. Slope from left must be equal to 0. Slope from the right must be equal to 0. That must be happening, okay, for that to be true. All right, what is derivative from the left?
3x squared.
All right, so from left, everyone, slope, f prime, from left is 3x squared. Now you got to plug in the x value, which is what? X equals 0. What's the slope from the left?
0.
0, okay. And when that slope from the what?
Left.
At x equals 0. Approaching from the left. What is the slope approaching from the right?
1.
And that statement's false. And the slope from the right, they're saying is a what? 1. You could probably see it in the image. Sorry. That's false. That's not true. That is not true. For that to be 0, both of them would have to be zeros. That's 1. So the answer has to be what letter?
E.
It's gotta be E. Let's see what they got for E. I haven't even read it. It's gotta be E. Gosh, they made us go through that whole thing to get the E. They said the slope is positive when x is not 0. Everyone look at our image. Is the slope positive?
Mm-hmm.
Yeah. Is the slope positive?
Mm-hmm.
No, so it's E. It's E. That's the true one. They're good though. They make you think. I like that. Not only do you do like, you get practice in this, you do some like, quotient rule and chain rule and stuff like that. Some of these make you kind of sit there and think.
Professor, if we do it like algebraically, like if for the odd function, if it like f of, I forgot, the odd function is like f of negative x equals to negative f of x, right?
Yeah.
That's for the odd function, right?
That's exactly right.
Okay, okay.
And when he's talking about the definition of an odd function is really this. F of negative x must come out to be mathematically negative f of x. Right?
Uh-huh.
That's the definition of odd function. You can do it that way.
Yeah, so if you do the one from the left, so f of negative x is negative x is x cubed, right?
Right.
And from the right, f of negative x is
Negative x.
So then both of them becomes odd function, but we have to do graphically then.
That's right. So I think what happens is we always got to look at the image.
Yeah.
But you're right. You said separately they're both odd. But if you make it a piecewise, we have to look at the
Graph, yeah.
graph. Great point too. We're saying we can't rely on that definition when we do a piecewise. We're gonna have to look at the image. Make sure it has that symmetry.
Well, are you going to, I forgot all those algebra. Are you going to have this something like this
What's that?
in the exam? Because I want to look on the algebra. I forgot those algebra. Odd function, even function, symmetry to x.
Oh yeah, I wouldn't do that.
Okay.
The cool thing about even functions though, everyone, when we get to area, a couple couple weeks from now, we do area under curves with the anti-derivatives, is when it's even, you only have to do like half the graph because of symmetry, and you just multiply the answer by 2.
Can you graph that on a calculator?
You sure can. Show you how. You got TI-84?
K83.
That'll work. So he wants to know how can you sketch a piecewise on a calculator. All right. Sorry I didn't bring my overhead thing, but you don't need it. Ready? The key is, remember this for piecewise graphs on a calculator? Parentheses. That's the key. All right. So I'd have to go to my y equals, and I'm going to put x cubed inside a parentheses. And then right after this, I'm going to start another parentheses, and I have to write this. So I'll put the letter x, but then this symbol, I'll put it in yellow. I'm going to tell you where that's located on your calculator.
It's under test.
Oh, he knows. There's a menu called test, and is it the left column? Where's test? Off the math?
Second math, yeah.
Second math, there's a menu called test, everyone, and you can actually get that symbol produced, and then close out the parentheses. But look, I didn't put anything between the I didn't put a comma or anything. I just went parentheses, parentheses. And then here, second one, do the same thing, x in a parentheses, and then x, grab that symbol, and then graph it. And it'll do it for you. It's kind of slow sometimes. It does one piece, and then there's a delay, and then it does the other piece. But it'll do it. Graphing it piecewise. Hey, the only time I don't like it is when it gets to like 3 or 4 pieces. Then I notice it's,
Then it's confusing.
yeah, I don't like using the calculator. I'm like, I'll do it by hand. But when it's 2 pieces, way to go TI-8384. I mean, it does a really good job making both pieces. Cool. Hey, can we do another thinking problem?
Yeah.
All right. It's a challenging one though. You'll get it. Anybody know how to solve a system of equations? I think I'll start with that and then we'll do it. Anybody know how to solve something like this amount, like 2x plus y equals 4 and x minus 4y equals 8? I'm just making this up. Anybody know how to solve a system of
Yeah.
equations?
You have to multiply. the-
Substitution method?
You can
Anybody do the elimination method or add out method? Either of them work. Cool. So something like that pops up in this problem. I want to give you a heads up about it. It was buried at the end of this practice set. Way at the end. Look at number 25. I thought it was good, but it is. That's why I put it last, everyone. I'm like, ooh. Yep. Because they're piecewise. We can't graph this yet, though, because they get constants in it. And it goes, if g is differentiable at 3, what's k now? So you got to figure out k now, huh? Cool. All right. We know differentiable means slope from left must equal what?
So from right.
But you all agree? If a function's differentiable, it must be what?
Continuous.
Easy as well.
Continuous and must have a
So I
limit.
say we start with that. Let's start with continuous. If it's differentiable, it has to be continuous. So let's start with continuous. What would have to be true for continuous algebraic?
It has
To be
slope.
connected.
Let's start with that. I'll put continuous. Left side equation must equal right side and plug in what for the x value?
3.
Brilliant. We'll start there. Everyone. Take the top equation. This is number 25. Take the bottom equation. Let's plug in 3 for x and set them equal to each other. Okay? That's what would have to be true. To be connected, they both got to be in x equal to 3, be equal to each other. Okay. So I get k times square root of 3 plus 1 must be equal to m times 3 plus 2. Does that sound good?
Mm-hmm.
Does everyone agree with me? To be continuous, isn't that what has to be true? Continuous at 3, these two sides have to be the same y values. Right here, like, same y. Same y value at x equal to 3, that must be true. Now, we took care of that. Do you notice, everyone? You got an equation with 2 different variables up.
Mm-hmm.
So then we move on, we look at differentiability. To be differentiable, we know slope from left must equal slope from right. Okay. I'm gonna do the easy one. You gotta help me with the hard one. the slope from the right, and when I saw it said mx plus 2. Do you agree the slope from the right is just m?
Slope
Does everyone
from-
agree?
Yeah,
Good.
M, yeah.
And the slope of this, and I'm like, But here's the hard one, you gotta help me out with this. What's the slope of that equation right there? So I need derivative of that. How do you get a derivative of square root of x plus 1?
Implicit
Power rule?
Product.
That k's a constant though,
Oh,
so we can carry the constant.
so it's gonna be.
So we don't need product rule, right? Some of you may be like, oh, it's two different variables, but that k is just a
So
what?
it's just a power rule.
Just a constant, so we can just do power rule.
Uh-huh.
So we can look at this as k times a parentheses x plus 1 to the
half.
half. All right, I want to do the differentiation, just let that k hang out in front, okay?
Uh-huh.
We don't need product rule, just, Josephine.
Slope from the right,
Slope from the right, you remember mx plus b? M is slope.
is that it?
Another way to do it though is, Josephine, think of anything like that. What would be the derivative of 3x plus 5 if you did derivative? Differentiation, wouldn't derivative be 3? Good. Or I'm gonna do it on 2x minus 1, derivative is 2, 5x plus 4, derivative is 5. That's another way to look at it. You can go, oh, m is the number in front of the x, so it would just be the m. Cool? So I want to differentiate that. What do you get? Let that k just hang out front.
So would you,
Half a k, decrease it by what?
One.
But I don't like how I wrote that. How could you write that better?
Divided by, like, the square root of k of x plus 1.
Good call, I'm gonna do that.
Wait,
All right.
what is, I don't know.
Oh, cool. So everyone, the hard work's done. I was just wondering if you had any idea how we could solve this system now. We got a system of two equations. I heard words like substitution. We just gotta solve
you
that
can
system.
multiply by k to get rid of the fraction, no?
No, so m is equals to that. So you take the k and multiply by 3 plus 2, and then you
Put it
can do
right
it.
there?
Yep.
I like that idea.
What?
What do you think about that, Amber?
Wait,
How about
what?
substitution?
I lost you,
Hey, how about the substitution method? Do you agree?
yeah.
You go, all right, we got our system of equations, true? We got this one from this side, we got that one from that side. And we're saying, well, if that's m, we could take this and substitute it into this equation for the letter m.
Oh, okay, yeah.
So what'd that become? I'll just draw an arrow. That means after substitution, I'll put it in yellow, I get k times square root of, what's square root of 3 plus 1?
2.
Are you okay if I write that as 2k?
Mm-hmm.
Is that 2k? Square root of 4?
Oh,
Wait, are
Cool.
we plugging in the k as well?
Do you agree that that's 2k? Square root of 3 plus 1 is square root of 4. And square root of 4 times k is 2 times k.
Wait, we're plugging in this entire.
I haven't done it yet though, just, I'm cleaning up that left side. Isn't that number right there 2?
Okay.
3 plus 1.
Yeah, 4.
Okay, square root of 4 is what? 2? But rather than saying k2, I could say what?
Okay.
Okay.
Just try it a little bit better. So now I get 2k equals 3 times, we're gonna put something in place of that m plus a 2. And let's bring it in here, what's going in here? Substitution. K over. And what am I plugging in for this x value? Oh, there's an x here, what could I plug in
3.
here?
3.
You bet, everyone, let's plug in x equal to 3. Remember this was about going on at 3?
Do you plug in 3 2 times?
What's that?
You already plugged in 3 with the mx plus 2. So you plug it in again when you substitute m?
This was the 3 from that side, and we have to plug it in again over here, you're right. Unless it was at x equal to 7, you'd plug it in x equals 7. So what's all that become?
So it becomes 2k equals to 3k over 4 4, 3k over 4 plus 2.
How much you need to solve for K here?
Yes, we can.
Get it right here. I went 2K equals 3K over 4 plus 2. Remember okay there?
Uh-huh.
I want to try and get ahead of you. Going all right to that point?
Yeah.
Cool. And now I know you can solve that thing. How we solve that? Want to collect your K's on one side? It's 2K minus 3/4 K. And like 2x minus 3/4 x. Yeah, it's 1 1/4 x, right?
Yeah.
What's that, 5/4?
Yep.
And isolate K, multiply 4 on both sides,
8.
divide to 5. Bam! I mean, that problem wasn't bad except for one thing, solve a system of what, equations?
Mm-hmm.
That's what I mean, that's what I want to say, that's what made that problem challenging. That's what I put last.
So m should be like 8/5 over 2.
Oh good, how are you gonna get M now?
Put the
You
k.
just put it back in. You go where? You can look at your work. Go, where can I find something equal to M? You might use it here. Look at that one. You got 2K equals 3M. You can use that one. Right? Anything you found easy to solve for your M on the board. I like this one. So 2K equals 3M plus 2.
Now we know what K is.
Now you know what K is. We can just put it right in there and get that M. Right?
Mm-hmm.
So
2/5.
I'll just go over here. 2K equals 3M plus 2. Translate this. 16/5. All right, what's 16/5 minus 2?
6/5.